All right, we made it. This is the last video that I'm going to do just about factoring, and then we can move on to our next section in Chapter 4. So here, we're going to factor when A, the leading coefficient, is not 1. We did a little bit about this in our first video of 4.4, but we're expanding on it right now. So in the past, if we go up here and look at example 8, the three terms in this quadratic do not have a greatest common factor other than 1. Of course, 1 will go into all of these terms, but nothing else will. So in this case, there actually is a possibility for us to have a greatest common factor because there is a 2 here. I can factor out a 2. So especially when you see that the leading term is not just x squared, you should look to factor out the greatest common factor. So seeing that the leading coefficient is a 2, I'm going to hope that we can factor a 2 out. All of these terms have even numbers in them, so we can factor out a 2. So remember, that means I'm going to pull the 2 out to the front, and I'm going to divide each term by 2. So when I factor 2 out of 2x squared, that is just x squared. When I factor 2 out of 14x, I divide that by 2 and I get 7x. When I factor 2 out of 20, I divide that by 2 and I get 10. So now we're looking at 2 times the quantity x squared plus 7x plus 10. Of course, I can't simplify the number 2 any further. It's pretty simple as it is. But I can simplify this quadratic using a method that we've gone over in the past. So we're looking for two numbers that multiply to get 10. So we want factors of 10. And we're going to look for their sum. And everything's positive there, so we're looking for positive numbers. So we can do 1 and 10, or we can do 2 and 5. 1 times 10 is, 1 times 10 is 10, 1 plus 10 is 11. 2 times 5 is 10, 2 plus 5 is 7. And we wanted a middle term of 7. So this quadratic factors as x plus 2 times x plus 5. Do not forget the 2 that you factored out in the first place. Without the 2, it's just equal to x squared plus 7x plus 10. If we factor a 2 out there, the 2 should still be in our final answer. So we can factor that quadratic as 2 times the quantity x plus 2 times quantity x plus 5. Or, of course, we could also write it as 2 times the quantity x plus 5 times the quantity x plus 2, as the order of multiplication does not matter. Okay, a couple more examples and we will be done with this chapter. So let's go on to example 11. Factor 3x squared minus 9x minus 162. I see that we're not just dealing with an x squared as the leading term, we're dealing with a 3x squared. You may not know off the top of your head that 162 is divisible by 3, but we're going to hope that it is because we want to factor this 3 out. So I know 3 goes into 3, I know 3 goes into 9. Does 3 go into 162? Or I guess I'll show you negative 162. Negative 54 is the quotient there. So we can factor out a greatest common factor of a 3. So if we factor a 3 out, we're left with x squared minus 3x minus 54. And now we're going to try to factor this quadratic. We need two numbers that multiply to get negative 54. And when we look for their sum, we're going to look for a sum of negative 3. So as always, we can do 1 and that number. So 1 times 54. We want it to be negative, and we want the sum to be negative, which means the bigger number should be negative here. That has a sum of negative 53, so we're still pretty far from negative 3 there. We could do 2 and negative 27, but that has a sum of negative 25. We're getting closer, but still kind of far off. 3 will go into 54 18 times. 3 and negative 18 have a product of negative 54, but a sum of negative 15. 4 actually does not go into 54. 5 does not go into 54. 6 will 9 times. So we can try 6 and negative 9, and those have a sum of negative 3. So now we know this can factor as 3 times x plus 6. The 6 needs to be positive, times x minus 9. The 9 needs to be negative. Or once more, it's totally fine if you said x minus 9 times x plus 6 with the 3 out front. All right, and the final example, here we are. Factor negative 5x squared plus 45. We see that 5 goes into both the terms that we can see there. There's not a middle term, but I don't have to worry about that necessarily. And we always want to factor out a negative if it's there. We want to match the sign here. So it's a negative 5 that we're pulling out. So factor negative 5 out of negative 5x squared, it becomes x squared. Factor negative 5 out of 45, it becomes negative 9. And now we want to factor x squared minus 9 down even further. There is no middle term, so we need to multiply to get negative 9 and add to get 0. Hopefully you can see where we're going here, but if not, I'll write it out. We need factors of negative 9, and we're looking for a sum of 0. So of course we could do 1 and 9, or negative 1 and 9, but those have sums of negative 8 and 8. That doesn't work. Remember, if we're trying to get a sum of 0, the number has to be the same. 3 times 3, it doesn't matter which one's positive and which one's negative. They have a sum of 0 and a product of negative 9. So this can be factored as negative 5. Again, don't forget that leading coefficient that we factored out, times the quantity x plus 3 times the quantity x minus 3. Or, again, you can do negative 5 times the quantity x minus 3 times the quantity x plus 3. And that does us for factoring. There's more to factoring, but that is all that I am going to cover in my regular Algebra 2 class. So we're done with Chapter 4, Section 4.